Okay, we're gonna start now. Anyway, I'll just give a little intro, so if more participants are coming, they should still have a few minutes time. So good afternoon, everyone, and welcome to this webinar called Up Your Tableau Table Calc Game. My name is Alessandro Costanzo, and I will present today. I'm here with my colleague Paul Hunt, which will help me to answer the question that you might send. Over the lesson, you can send your question through the chat, and we'll try to answer as soon as possible. Okay, so in today's webinar, I will start giving you an introduction to the topic, so table calculation, in which I will cover the definition of calculation, table calculation, and quick table calculation. And I will then move on to show you how you can translate a table calculation in an English sentence. After that, we'll start the actual lesson. So I will provide you a live demo. You can follow along the exercise I will do. I based everything onto the dataset sample superstore in Tableau. So as long as you have access to Tableau, you should be able to follow along the exercise. You don't have to, though. I'm planning to package this workflow and send it in the comment after the lesson. This package workbook will contain all the solutions, so you'll be able to reverse engineer what I've done and practice yourself some extra table calculation. Okay, so just a little bit about me before we start. So my name is Alessandro Costanzo. As you might have noticed from my name, I come from Italy. I joined the Information Lab this year in February. I started in the data school program. So this program is composed of 4 months of training. We're getting close to the 3rd month here. And I joined the data school just after my graduation. I graduate actually in hospitality management, so something completely different than data analysis. But I think that's a good sign that now data is becoming very democratic and everybody without a specific background can actually get into this field. So during these 3 months so far, I've received a high standard of training from experts in the field, renowned worldwide. And I'm now here to delivering the Information Lab mission, which is to help people make sense of their data. And I hope today's lesson will help you to understand better your data as well. Just to clarify for the question, you can send them using the chat. Do not use the Q&A because I don't have access to that, unfortunately, but Paul here with me has access to the chat. So you can just type in there and he will answer as soon as possible. Okay, let's start the real thing. So the first thing, talking about table calculation, that I want to explain are the concept of calculation. Many of you might know, but this might be something new for others, so I would like just to give a quick intro. So a calculation, the definition of it is a field generated by the software, which was not originally present in the data set. If you look at this picture here, it will show you the actual stage that Tableau computes to get the data. So whenever you're dragging and drop any field, for example, a customer to the column shelf, what Tableau does is send a data query to their data source, which can be an online data source or some file that you have stored on your local machine. And it gets some aggregated result here. These aggregated results are stored in the local data cache and then are used in the visualization. So a calculation occurs at this stage when Tableau has the cache from the data source and can apply calculation onto it. Just to give you an example of how a calculated field would look in Tableau. Just open it up. And I will actually show how to get to the data set we're going to use, which is Sample Superstore. So as soon as you open Tableau, just double click Sample Superstore here, and you're in. We have the same working environment. So if you pay close attention to the icon next to your measures, you can see that some of them have just a symbol, for example, the hash key here, and in some other, this symbol is integrated with an equal sign, as you can see here from the profit ratio. So that defines a calculation. Therefore, if I just right-click and go into it and edit, you can see that this field was generated doing a sum of profit divided by the sum of sales. I was able to go into this calculation, into this field, because it is a calculation. For fields that are coming from the data set and they don't have the equal sign, this option is not available, because that's the data you would get just before the cache. So that's data coming from this point. Sorry, bit of problem with my slide. There we are. So that's the data which come from here, if it's not a calculation. Okay, moving forward, table calculation, which is our main aim of the day, is, so the definition of it is a calculation that applies only to measure and dimension present in the view. This means that if you're changing some of your measure or dimension, the calculation outcome will actually change. But let's dive into Tableau and let's start with some example which may make things easier to understand. So for the first example, I'm dragging order date onto columns and I expand that to quarter. I'm then dragging category onto the row shelf. And I'm then dragging the sum of sale over the field. And this, as you can see, generates the table. As we were taught at the data school, the best way to understand the table calculation is actually to start with a table. So as you can see here, we built what we call a crosstab. And it will be easier to understand what the calculation is actually doing. So from here, if you go onto the analysis menu, totals, and show the row grand totals, and do the same for the column grand totals. So this, as you can see now, added some totals at the end of our rows and column. The first example I will go through is one of the quick table calculation. To apply one of those, simply go to the measure that you want to calculate against, right-click onto it, and add table calculation. This pop-up menu will appear. And let me just go back to the slide so I can explain you how to read and translate the pop-up outcome in an English sentence. So as you might just have seen, the quick table calculation are those kind of calculation embedded in Tableau. So you do not require to write any formula like we've seen just before with profit ratio. They do have a defined scope and direction, which I will explain when we go into it. So just to give a quick guide on how to read this table calculation, This was something that our coach Andy Kriebel provided us and really helped us to understand what those table calculations mean. So looking at the pop-up menu, you would read it in this way. The fields that are unticked are the first one. So you would read for each year and quarter, then jump to the calculate and just read the calculation. So calculate the percent of total by category and subcategory. So if we want to read the example here completely, you can have a look at this. So for each year and quarter, calculate the percent of total by subcategory and category. Of course, I will share these slides at the end of the session, so you can use this to practice on how to read the table calculation and see making sense out of it. So let's use the same example we just seen on the slide. So we have our quick table calculation pop-up menu here. If now I select percent of total, you can see here Tableau already computed some percent of total. Before I spoke about direction and pane and scope. So the direction are those two, across and down. Looking at the grand total can make you understand better what this calculation is doing. So if I'm calculating across the table, you can see that Tableau is calculating the percent of total across the table. So it's counting how much every quarter of the year accounts to get 100% of total. Likewise, if I change this to table down, you can see that Tableau is showing you where the calculation is taking place. So over here. So now we're calculating down the table, and you can see that the percent of total is calculated against the categories. So those are the two options, table, pane, and cell. I will explain when we have other examples which are more suitable for that. So for the moment, let's just do a recap on how to read them. So for example, when we have a table across, in this scenario, we would read for each category, compute the percent of total by year and quarter. Whereas if I change this to table down, the calculation would be written in this way. For each year and quarter, calculate the percent of total by category. Another tip given to us from our head coach was, once you find the right type of calculation that you want, to switch this to specific dimension and then close the calculation. This will actually lock the calculation against those specific fields. And due to this, even if you change some element of the table, the calculation will remain the same, as long as you don't remove some elements of the calculation itself. Okay, so now that we have a nice percent of total calculated, since we're using a data visualization software, we can have a look on how to make this pretty and visualize it in a nice way. So if I now drag sum of sales over the row and move category to the color, we get a nice spaghetti chart, as we like to call it here. But that's an easy fix. So just change your mark type to bar. And here you are. So now you have a nice visual way in which you can see how much each category accounted for the 100% of total for each quarter. Another hint that can help you to calculate is to can help you understand which kind of calculation you've done is looking at the percentage down here. As you can see here. So now I've got 1600,000%. So that means that I've got 16 different fields, all of them adding up to 100%. Although I still suggest, especially if you're a beginner, to build the table first and to verify your totals using the grand total row and column. Okay, moving forward, just wanted to iterate a little bit more on what we need, what we define as a scope and direction. So let me just recreate the example we had before. I'll use order date, in year and quarter, and the category in a row shelf. I will then use sum of sales again, just to show you some number. So just to recap again, right click on the measure, add table calculation, and here we are with our pop-up menu. Let's change this to percent of total. And let me actually add the total again from analysis, total, show row grand totals, and show column grand totals. Okay, so you can see now we are calculating across the table. Going back to this menu using edit table calculation. And now let's pay attention. So we already explained what the two directions mean, across and down. But it can also have a defined scope. So my scope can be my entire table, which would give us actually a percentage of each of these marks on the 100% total. Or it can be just for a single pane. So for example, just till here, so just for 2015. And to look at this even better, we can add from the analysis the subtotals. So adding the subtotals here will actually show where the 100% occurs. So it might be another way to help where you are calculating. So if we just show the menu, you can see that now the percent of total is calculated by pane, and it restarts at each year. So I calculate against every quarter of a specific year. The cell option actually calculates every single cell. It might look weird because all the detail are 100% now, but I've got an example in which this type of calculation can be useful. And I need to credit Paul here next to me because he showed me this type of calculation. I was wondering what the cell button was for, and he showed me. So let's take this example. We have sum of sales on the columns. And segment onto the rows. So as you see here, we have three segments: consumer, corporate, and home office. And let's drag the category onto color. So now Tableau is showing me how much this furniture, office supplies, and technology accounts over the total consumer, corporate, and home office segment. So here, if I apply a table calculation, like before, we can do percent of total. And I'm calculating against the cell. So each of these segments now represent a cell. And as you can see now, each of these cells adds up to 100%. You can again double check this, just checking at the percentage total sum. So it's 300%, meaning that for each of these segments, we have 100% of the total. And that's one example when calculating using the scope cell can help you with your calculation. Okay, moving forward, we've done only percent of total so far, so I would like to show you other example of table calculation you can apply. So let's open a new worksheet, and let's drag sum of sales onto the view. Let's drag order date onto the view. And just a quick tip, if you drag it by right-clicking instead of left-clicking and leave it on the columns, Tableau will pop up a menu in which you can select the type of date you want to show. If you'd like a continuous date, show it in green, or a blue type of calculation, so a dimension. I'll just do this again. So if you go to any date field, the one in which you can see a little calendar as an icon, right-click and drag them onto the column shelf. Now, for this example, I will use week or the date. So the data will be a continuous type of data and will be divided by week. So let's have a look at our sales over this 4-year span, approximately. As you can see, there are a lot of spikes. And for many type of calculation, this, especially if you're trying to spot trend, can be difficult. And that's when the table calculation moving average comes in handy. I will show you what this moving average do. So if you drag again sum of sales next to the first one you have, so duplicate the field, you will now have the two times the same view. If we go onto this view and apply a table calculation, and switch this for a moving calculation. What a moving calculation does, it basically smooths down the values, so you can better see trend even if they are full of spikes up and down. So you can choose which type of calculation you want to do. The type we want to analyze is the average. So we're doing a moving average. And since we are computing weeks, these values you can see here, the 2 and the 0, defines how many weeks you want to look at before and after the current date. So if, for example, we do a 6 previous and 6 after, we'll have roughly 12 weeks. So we can say that roughly is a moving average by quarter. Closing this, you can see the difference. Now the old spiky chart is replaced by this one, much more smoother, and it can help you to see like an increasing trend, which was difficult to display here. If you want to see even better how these two calculations compare to each other, you can go into the green pill sum sales where you apply the table calculation. By the way, forgot to mention that once you apply the table calculation to one of your measures, you will see a little delta sign next to it. This little sign means that the table calculation was applied to that field. So let's just right-click on the field we just created and press dual axis. Dual axis the chart, and now the two charts will be together. The only thing you need to be careful after that is to remember to go on the second axis, right-click, and synchronize the axis. So now the two axes will have the same start and end. So comparing the two charts, I think that the moving average can help you to understand growing or decreasing trend without worrying too much about these spikes. And as you can see here from the blue line, we can see an increasing trend, which was difficult to spot before. Okay, let's move to the next type of calculation, which is the difference from. For this exercise, let's drag all the date simply with a left click onto columns and leave it at the level here. And then let's drag category. And for a change, let's drag quantity onto the view. And here we have our table showing how many quantity with the number of quantity for each year and each category. If we are interested to find the difference of those, we can right-click on our measure, add a table calculation, and our pop-up menu will come. So now we can leave it as it is. The first type of calculation you see is actually difference from. And as before, we can choose where to apply this. So it can be across, it can be down, down and across, and by cell. So let's take the first one, a table across. So what you can see here, there is something that wasn't there before. So the pop-up is asking what you want this calculation be relative to. At the moment, the calculation is set to be relative to the previous value. So what Tableau is doing is not showing anything for 2015 because we don't have any value for 2015. I mean, because the 2015 is the first value, so it cannot be compared to any previous one. That's the first value of the data set. So what Tableau is showing now is that in 2016, we had an increase of 152 units in furniture, and that in 2017, we had an increase of 418 compared to 2016. If you're interested to find the overall increase, so for example, you want to see how what was the difference in quantity from 2018 to 2015, you can change this using the relative to button. So switching this to first will now calculate everything against 2015. So in 2018, in the technology category, in 2018, we had a difference of 974 pieces against 2015. It is important to make sure you are setting this calculation right, especially for specific purposes, because using it, for example, as calculation down and closing, if I don't have any information, I might assume that the furniture, the number of furniture has remained the same throughout the 4 years, whereas the other two categories have been more fluctuant. But we know this is not the case. We are just calculating something that I don't think will be useful. So we're actually calculating against furniture as the first, instead of taking our 2015 as the first value. So let's change this calculation back to table across, and let's fix it using a specific dimension. So the other two options available here were next and last. So like previous and first, using next, we'll actually look at the next value. So in this case, it's 2018 that doesn't have any value, because of course there's no value afterward. There is no year to compare. And all this year will relate to this. So, sorry, the 2017 now will relate to 2018. So we can see in 2017, we had negative difference of 244. And 2016 compared to 2017 had a negative difference of 418. Changing this to last, we'll do the same as first, but the other way around. So now we are comparing everything against 2018. For example, in technology, in 2015, we sold a negative of 974 compared to the last year, 2018. Using the same type of calculation, I'll just duplicate the sheet. We have the same starting point. Just to show you, table calculation can be cleared as well. So whenever you see the delta sign and you want to remove the table calculation, you can just right-click and clear the table calculation. So now right-click and add the table calculation. And instead of the difference from, we can do the percent difference from. This shows the same type of calculations. So for example, we can relate to previous, next, first, and last. But this will actually give us the value in percentage. Like before, you can choose a defined scope and direction. Very useful, especially to spot trend and year-over-year sales. Moving forward, another type of calculation that is actually very demanded in business environment is the running total. So the running total defines the quantity we have sold, for example, from the first day till the last. And we can see how this amount has grown over time. To do so, I will right-click order date onto my row field. And let's use a discrete, so blue week order date. Do correctly. Yeah. Sorry, wanted an exact date. So you can just right-click here and press exact date and then discrete. Perfect. That's what we wanted. So I want to see every single day in my data set as a discrete field. So to do so, just drag order date, right-click to exact date, and then right-click again and set it as discrete field. And now we can add sample sales over here and seeing all the different sales per day. Adding a table calculation in this case. So right-clicking and adding a table calculation. And doing a running total, sum, because we want to see how these add up together. And table down. Close the calculation, and you can see that now, compared to before, let me just make this a bit bigger. Sorry. Cannot in this type of view. So this now is calculating a running total. So each day is adding up to the previous one. And that's how it goes till the end of our data set. So you can see the actual total amount we gained since our first sale till today, or till the latest date in your data set. Just to make this a bit visual, we can, using this button, moving this order date onto the columns and moving sum of sale onto the rows. switching this order date to a continuous field now, will show an increasing trend. So this will represent our running sum of sale. And possibly switching it to either area or bar will actually give a nice area to see, nice area chart in which we can see how our sales are increasing over the time. You can also apply the table calculation to multiple fields. So let's say we're dragging profit as well as sales, which is something we might be very interested in, to see how the profit and sales are growing over time. So let me just clear this table calculation just to show you. So those are the sum of sale and sum of profit over time, visualized using a line chart. So this kind of visualization might not say a lot about it, but look, just applying two table calculation, which by the way, you can apply also by using quick table calculation menu here and running total. And let's do the same for profit. Only one piece of advice when you're using this pop-up menu, just be careful because Tableau does the automatic default aggregation, direction, and scope. So you might want to double check, especially if it's the first time you're using these tools. So once we calculated the two running total, like before, we can go to the second field and dual axis them. If now you remember, just synchronize the axis. And now we can see we have a nice area chart which shows us how the profits are growing compared to the running sum of sales growing. And we can see the profit are getting actually bigger, which is always nice in a business perspective. Okay, next type of calculation I'm going to show you is the rank. To do so, I need, so for this example, either follow along or I'll give you a little bit of time because I need to actually create a calculation because I wanted to show some different fields. So for this example, let's move our state onto the rows. And let's move, and let's add a filter. Sorry, that will have to be later. So let me first create this calculated field. And to do so, we can go here, press create calculated field, and we'll call it 500K, 5,000 bin. So 5K bin. The calculation I'm writing is floor, sum of sales, divided 5,000 and then times 5,000. So I won't go too technical with this calculation. I will just leave it for a few seconds in case you want to copy. So what this calculation is doing, just to make it simple, is dividing this number to 500 and is basically aggregating the value to the next 5,000. I will need to do that because I want to rank these states, but I want to show you what happens when few states have the same value. And it's very difficult to do with the actual value. So as you can see here, after this calculation that we just done, all the fields end with either 5,000 or 10,000 multiples. So only with multiples of 5,000. If now we sort these using this button on the top, and we can see how they rank from first to the last. Okay, if now we apply a filter on the state, so just drag this to the filter, and let's just keep the top 20. So we'll just want the top 20 states by our new formula, 5k bin. And there we are. We just have 20 states, which will be better for the purpose of this exercise. So let's show you the rank function. What the rank function does is basically give them a rank. So there will be 1, 2, 3, 4, ranking them from the first to the last. Although I wanted some states to have the same value because I want to show you the different type of rank. Therefore, let me just drag our new created field onto the view. And let me change this to a discrete field. And let's just move this before the state number. So if I apply a table calculation to this, and let's go to rank. Here you can see how Tableau is computing the calculation. So there we have number from 1 till 8. And here, as you can see, Ohio and Michigan have the same rank because they have the same score, 75,000. So what happens to the next number? It will jump to 10. And so on till we have another group of three states with the same amount, 35K. So now the number will jump from 14 to 17. Another group of 3, and then we have the last state, Delaware, rank number 20. If we change this using this pop-up menu and changing the competition, we can see which kind of different rank we can apply to the view. So the one we're using now is competition. We can change it to define modified competition, which is pretty much what we had before, but now the value 8 and 9, for example, gets rank as the last one. So we are skipping 8 this time and jumping to 9. And we are skipping 13, we're keeping 14 and 15 and jumping to 16, 19, and so on till getting to 20. Changing this rank to dense, we can see now that the states with the same rank just get the number 8, so we're not skipping anything. So they're both getting 8, and then we're going to 9, 10, and the last one, since we have so many multiple values, will be 15 instead of 20. If instead we want, for example, a table that would say 1 to 20 regardless of any similar value, we can use the rank unique. Using the rank unique, Tableau will get rid of the differences here and will still rank them by every different number. Since they have the same value, the state with the same value will be ranked using alphabetic order. One quick thing I want to show you is that for every time you apply a table calculation and you have the delta sign, you can just move this back to your measure or dimension, and this will create a calculated field. So if you do that, you can go inside and edit by right-click, and you can actually see how the calculation was written. This can help you to find how Tableau actually compute this result, and if you get deeper enough, it can help you to customize your table calculation. Another function I want to show you before the end of this webinar is how to apply this to write a table calculation, because there are some functions that can only be written, they cannot be found on the quick table calculation. So using again my order date as a year and quarter, and dividing this by category, and let's drag the sum of quantity over here. After that, we will have to create a calculated field. And for this calculated field, I will use the table calculation function called Windows average. So Windows, as a function, can be applied to sum, average, of any other mathematical function. We'll find the average in this view. So for example, doing this and doing Windows average sum of quantity, we'll define the average of all the number in this view. If I make this calculation a Boolean now, so let's say I want to see if the sum of quantity of each of these marks is above or equal to the window average of sum of quantity. So the actual average of the number we have in the view. So what this calculation means is find me which one of these are above the average of all of them. So let's just, as you can see, the calculation is valid. So just click onto it. We have a true, false, so a Boolean value. It can be either true or false. And let's drag this onto the color. And as you can see now, the value above the average are in one color, orange, and the other one are in blue. So window average can be used for every type of mathematical function. If you want to find out more about that, I invite you to play a bit with it. Open the Create Table Calculation windows, go to All, get down to Table Calculation, and here you can see all the type of table calculation that you can actually write as a calculated field, including all the window function. Okay. Time flies. We are actually running out of time, so unfortunately I cannot show you any more example. I would just like to leave you some of my contact. If you'd like to know a bit more of the topic, you're more than welcome to send me an email at alessandro.costanzo@informationlab.uk. You can contact me on Twitter, LinkedIn, or have a look at the blog post that I wrote on the Data School blog and in my personal blog, Get Into Data. And just to give you some other resources, here we got the link of the official explanation on table calculation from the online Tableau help, and a very interesting video that I actually use to get many ideas on how to provide this session, made by our head coach, Andy Kribel, in which explain in detail table calculation and gives you a good overview of the topic. I will now share the workbook I'm using for the exercise with the complete exercise, so you're going to be able to reverse engineer it and test your skills on table calculation. And just as a reminder, on other resources, I'll invite you to join the meetup group called Let's Talk Data, in which the Data School organizes many events like this webinar, and also event in person in which you can attend here at the Data School in London. So thanks everyone for listening. I hope you enjoyed this session and it was useful for you. Please let me know what you think, and I'll see you next time. Thank you.